In a new exciting research, Apple has come up with this denoising LM or denoising large model. DLM for short, it is a scaled ASR error correction model that leverages synthetic data and learns the proper error distribution. For the first time ever, they have shown that state of the art WER can be achieved with such error corrections modeled on the well known Libri speech benchmark, and that error correction models are able to outperform conventional neural language models by a large margin, and that is something to say because this field is already saturated. Language models have long been used to re-rank hypotheses produced by automatic speech recognition systems or ASR. In order to do so, the agnostic score of each hypothesis from the ASR is blended with the LM score for the hypothesis. But language models are trained on text corpora and are agnostic to the mistakes made by ASR. So significant work has gone into developing techniques to train these automatic speech recognition or ASR systems that incorporate an existing LM so that the combined system works well. Error correction models, on the other hand, are trained specifically to correct errors from the ASR models mapping hypothesis, which in other words, you can say that separating out noisy text from the ASR systems to the clean text. So it sidesteps the problem of learning the correct weighting between the LM and the ASR. This can be an especially useful strategy when the ASR model has limited capacity and cannot produce structured output, for example, with non-autoregressive ASR models. In those cases, a sequence-to-sequence error correction model can turn approximately correct outputs into structured outputs. Also, it can take the text normalization role, simplifying the overall pipeline for ASR systems. If you look at this diagram, this is where conventional LM decoding and the proposed DSR coding is happening. On the left panel, given an input audio, an n-best list of the hypothesis from the beam search decoding of the ASR model is generated with a n-gram word level LM, which is then rescored using the neural LM scores and ASR scores. If you look at the right panel, given an input audio, ASR generates its greedy hypothesis, which is fed into DLM, and it generates an n-best list of the corrected hypotheses, which are then rescored using both DLM scores and ASR scores. And that it is what it is all about. So in this paper, what they are doing it, they have proposed this denoising LM or DLM, which is an ASR error correction model that uses text to speech or TTS system to avoid this data scarcity issue. That is all it is doing. Text from a language model corpus can be fed into the TTS system to produce audio, which is in turn fed into an ASR system to generate hypotheses. These hypotheses are then paired with original text to form the training data set. The amount of training data can then be scaled up arbitrarily by using a larger language corpus. So all in all, the DLM looks very promising from Apple. They have also presented a working recipe in the paper, and I will drop the link to it in video's description. And there are several key ingredients that distinguish DLM from previous attempts. First, they have used a multiple zero-shot multi-speaker TTS system to generate audio in different styles. Secondly, they have mixed real and synthetic data during training to keep the DLM grounded. And then they combine multiple noise augmentation strategies such as frequency masking of spectral features and random substitutions of characters of ASR hypothesis. So there are three characteristics which have been demonstrated from this research. First, the universality. What it means is the same DLM is applicable to ASR systems of different architectures. Then comes scalability. That means the performance of DLM improves with the increasing number of speakers. the size of the model, and the size of training text corpus. And then lastly, there is an efficiency. So DLMs can match traditional neural LM results by simply performing greedy decoding with no need of heavy beam search decoding and rescoring. The success of DLM suggests that instead of complicated LM integration techniques, error correction models show more promising possibilities to bring the next level ASR accuracy. And that is why I believe that Apple is going to embed this model very, very soon in its product. And I think this might be adopted by other tools too. That's it, guys. I hope that you liked it. Let me know what do you think. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.